Good morning, students. Today we are going to see structure and bonding in organic molecule. First of all, what is meant by hybridization? The phenomena of mixing of pure orbital to give set of new equivalent orbital is termed as hybridization. So what are the rules of hybridization? The orbital of similar energy take part in hybridization. It is first rule. The number of hybrid orbital formed is always equal to the number of atomic orbitals which have taken part in hybridization. It is the second rule. Hybrid orbitals form only sigma bonds. It is very much important. It is the third rule. Now we are going to see sp3 hybridization. In this type of hybridization, all three 2p orbitals mix with 2s orbital, just like this, to produce 4 equivalent and identical orbitals. The 4 newly formed orbitals are directed towards the 4 corner of regular tetrahedron and make an angle of 109 degree 28 minute with one another, which is shown here. The two orbitals are termed as, the new orbitals are termed as sp3 orbitals. This type of hybridization takes place in the formation of compounds containing only single sigma bond. For example, methane and ethane. So, just see, it is your ethane molecule. In this ethane molecule, your carbon undergo sp3 hybridization and a set of 4 hybrid orbital with a tetragonal arrangement is obtained. Then each hybrid orbital overlap with s orbital of hydrogen. So there are 4 hydrogen atoms. So we get 4 sigma bond. In a ethane, just see, this carbon which is here and this carbon which is shown here. These 2 carbon basically undergo sp3 hybridization. The bond length of this carbon to this carbon, it is 1.54 angstrom. So this is the diagram for ethane molecule. In ethane molecule, one of the hybrid orbital, that is sp3 hybrid orbital of this carbon and sp3 hybrid orbital of this carbon overlap with each other and going to be formed sp3 sigma bond, because sp3 hybrid orbital overlap with each other. In this case, here and here, 3 hybrid orbitals overlap with s orbital of hydrogen, going to be formed again sigma bond with the hydrogen atom. Same case is here. The bond angle is of 109 degree 28 minute in this case. Now we are going to see sp3 sp2 hybridization. Best example for sp2 hybridization is ethylene, that is CH2. In this type of hybridization, the 2s and 2 of the 3p orbitals, say 2px and 2py of the carbon atom, are hybridized, leading to the formation of 3 equivalent sp2 orbitals which lie in same plane and make angle 120 degree with one another. The third 2pz orbital remains in its unhybridized state. It is important and is perpendicular to the plane containing 3 sp2 hybrid orbital, which are shown in the figure. So just see, in this case, one 2s orbital, and out of these 3 2p orbital, your 2px and 2py orbitals with 2s orbital undergoes hybridization, going to be form 3 hybrid orbitals which are lie in one plane. So this is basically sp2 hybrid orbital which are lying in one plane. They make angle of 120 with each other. Your 2pz orbital is basically perpendicular on these 3 hybrid orbital. So this is the overall picture. So it is the 2pz orbital which is unhybridized, and these are sp2 hybrid orbitals. So this type of arrangement, it is known as trigonal arrangement. The trigonal arrangement takes place in the formation of compound containing double bond between 2 carbon atom. So just see, in your ethylene molecule, this carbon and this carbon undergo sp2 hybridization. So just see here, this and this is your sp2 hybrid orbital which are lie in one plane with trigonal arrangement. Other carbon also undergo sp2 hybridization, which are shown with marker, and this sp2 hybrid orbital also arranged in trigonal planar arrangement. The unhybrid orbital, that is 2pz orbital in both the carbon, is shown with dotted line. In this case, this carbon and this carbon forms a sigma bond with sp2 orbitals are overlap with each other. So they are going to be a form sigma bond. These sp2 hybrid orbitals are overlap with hydrogen 1s orbital of your hydrogen. Now the unhybridized orbital which are present on both the carbon, that is 2pz orbitals, they laterally overlap with each other. It is parallel overlap. So they are going to be a form pi bond. So bond angle in this case, it is of 120. Carbon-carbon bond length is 1.33 angstrom. Now we are going to see sp hybridization. In this type of hybridization, only 2s and 2px orbital are hybridized, forming 2 equivalent sp orbital which are collinear. The 2py and 2pz orbital remain in their natural state. This gives rise to equivalent bond pointing in opposite direction along the straight line. It is important. If the two bonding orbitals, one is oriented along the y-axis and other along the z-axis, the diagonal hybridization or sp hybridization, your sp hybridization is also known as diagonal hybridization, occurs in compound containing triple bond, 2 carbon atoms So example in which sp hybridization is seen, it is acetylene, that is CH triple bond CH. So in this case this carbon and this carbon undergo sp hybridization. So one of the hybrid orbital overlap with other hybrid orbital of other carbon and going to be form sp overlap and going to be form a sigma bond. The remaining hybrid orbital is overlap with 1s orbital of hydrogen and going to be a form sigma bond. Now there are two unhybrid orbital, that namely 2py and 2pz on your both the carbon. They overlap in parallel manner and going to be a form pi bond. That's why acetylene contain 1 sigma and 2 pi bond. Now we are going to see the topic of bond length, bond energy and bond angle. So what is bond length? When two atoms are bonded by a covalent bond, the distance between center of the two nuclei is called bond length. Bond length are measured by X-ray crystallography and by microwave spectroscopy. The unit of bond length is Armstrong. 1 Armstrong is equal to 10 raised to the power minus 8 centimeter. For most bond, the values are 1 to 2 Armstrong. What is bond energies? Bond energy or bond strength is defined as the amount of energy required to break a bond in a molecule. Bond energy depends on the type of bond as well as structural environment in which bond is situated. They are determined by quantitative measurement of heats of chemical reaction, that is calorimetry, and by spectroscopic method. The unit of bond energy is kilocalorie per mole or kilojoule per mole. Now what is meant by bond angle? All atomic orbital except s orbitals have directional preference. Hence covalent bonds formed by their overlapping are also directional and have an angle between them. The angle between the direction of two covalent bonds is known as bond angle. Now just see this table. First column is for hybridization, second for percentage of S character, third is for bond length, fourth column is of bond energy, fifth column is of bond angle. So in sp3 hybridization, example of sp3 hybridization is methane and ethane. But if we calculate percentage character of s orbital in sp3 hybridization, it is 25%. And the bond length in both these molecule, the bond length between carbon and hydrogen is 1.10 Armstrong, while carbon-carbon bond length is 1.54 Armstrong. Bond energy for carbon-hydrogen bond is 434.72, while for carbon-carbon bond it is 368. Bond angle is 109 degree 28 minute. For sp2 hybridization, example is ethylene. Percentage S percentage character, that is character of s orbital in this hybridization it is 33%. So just see what happens with the bond length of carbon and hydrogen bond. It is about 1.09 Armstrong degree. Bond energy is 443.08. For carbon-carbon double bond, bond length is 1.33 Armstrong. Bond energy value is 636. Bond angle is 120. In sp hybridization, example is acetylene. Percentage character of s orbital is 50%. Just see what happened with the bond length of carbon hydrogen bond. It is 1.06. Bond energy value is 505.78. Carbon triple bond length is 1.20 Armstrong. Bond energy value is 837. Bond angle is 180 degree. Now from this table we can say that as the percentage of s orbital, percentage of character of s orbital is increases, we see that bond lengths are decreases. Just see this value. In this case, in sp3 hybridization, the bond length value is 1.10 Armstrong, while in sp2 hybridization, the bond length value for CH is 1.09 Armstrong. For sp hybridization, the bond length value between carbon and hydrogen is 1.06. So bond length is decreases when s character increases. Since bond length is decreases, it simply means that bond energy is increases. In our next class, we are going to see inductive effect and electromeric effect. Thank you very much.